equal to 0. Okay. And there's a bunch of different types of factoring that you learn at some point. One is the greatest common factor. 2 is the difference of squares. 3 is what's called a perfect square trinomial. 4 is what I call a equals 1. That refers to this value here. And the one that we have here is when a is not equal to 1. That's the hardest type. That's the grouping. It's a grouping approach. So to solve, or to factor this, first thing you try is you take the 2 and you multiply it by the last number. So 2 times 10. If it were negative 10, it would be 2 times negative 10. You get 2 times 10 is 20. And what you're looking for now are two numbers that multiply to 20, but add to negative 9. Add to negative 9. So that means they're going to be both positive or both negative to get to 20. Since you want negative 9, they're going to be both negative. So can you think of those two numbers for me that multiply to 20 but add?
Negative 5.
And what's the other one?
Negative 4 and negative 5.
Very good. Okay. All right. Now, the next thing here is what you're really doing here, and hopefully this is all review, nothing new here. What you're really doing is you're taking this negative 9x and you're breaking it up into negative 4x minus 5x or minus 5x minus 4x. And the way you choose is like which one pairs better with the 2x squared. And you probably agree it's the first one. The minus 4x is going to pair better with the 2x squared. Okay.
Yeah.
And you do kind of want to look ahead to that because it will help when you're doing the next part of this problem, which is the grouping. So you're grouping the first two terms here, and you're trying to figure out what is the greatest common factor between those two terms.
So 2x.
Yep. So it's 2x out of both, and then you get x minus 2 inside parentheses here. You immediately write what's inside parentheses over here on the right, and then you figure out, well, what goes in between such that when you multiply in, you get back to the previous line. It ends up being minus 5.
Okay, that one, yeah, that makes more sense.
And we're almost there, and I really like calling it double factoring instead of grouping because you end up factoring twice here, that x at least twice. You pull an x minus 2 out, and then you have 2x minus 5 equals 0. But we're not done. Like all we've done up to this point is the factoring. But just make sure you're clear on where the 2x comes from and where the minus 5 comes from. And now to actually solve, you set each of these equal to 0.
So then it's 2 and
So you'd add 5, right? 2x equals 5, and then divide by 2. X equals 5 halves.
and that's zeros for that one.
Yep, those are the answers. So there, my perception when I help students is that there's no one thing here that's difficult. It's just all of it together. It's just knowing all of these things to do to get down here to the final answer.
Yeah.
Okay. So any questions before we move on to 3?
Can we do another zeros one?
Yes. Do you want it to be like this?
Yes.
Okay. All right, give me just a moment to find one. So it would look, this one's 2x squared minus 5x minus 3 equals 0. Do you want to try this one on your own, or do you want me to work through it for you?
Can you walk through it?
Sure. So first thing is because the leading coefficient is not a 1, and because this number 2 doesn't go into any of the others, you then have to multiply the first and the last. 2 times -3 is -6. And now what you're looking for is two numbers that multiply to -6, but add to -5.
So -2 and -3.
So those do not add to, do not multiply to -6. They do add to -5, but they don't multiply to -6. They multiply to +6.
2 and 3. No.
So same problem, right? Like so in this case, one is positive and one is negative. And it's not these numbers. So you got to find the other.
6 and -1, or yeah, 6 and -1.
Okay, so these multiply to -6, but they don't add to -5. They add to +5.
-6 and 1.
Right. And I can sense just the frustration, right? Like it's like, like, but that is the essence of this problem. Okay.
Yeah.
So this right here becomes -6x plus 1x, 2x squared minus 3 equals 0. And what is common between these two?
3x.
3 does not,
2x.
2x, there you go, yes. And so tell me now, what goes in parentheses?
X minus 2.
You said 2?
Yeah.
So 2 times 2 does not get you back to 6. You got to get back to 6.
X minus 3.
Yes. Okay. Now you immediately write what's in parentheses over here to the right. And you have to figure out what goes here such that when you multiply in, you get back to the x minus 3. What would that be?
The +1.
+1, yeah. All right. And then it's really double factoring. Both of these have an x minus 3 in them. And so you pull out a 2x plus 1 like that.
And then you just set them to 0 to solve.
Let's go ahead and solve those for me, please.
Is it 3 and then 1/2?
Okay, how do you undo +1?
By subtracting 1.
Yeah, so that makes it negative. You got 2x equals -1, divide by 2, divide by 2, and x equals -1/2.
3 minus and -1/2. Okay.
Okay, so let me really quickly have you solve a couple of these that I think could be just why don't you try give me the answers to these two real quick, just to review solving.
For these ones, do you multiply the first and the last number to start? Like, do you multiply 3 and 4?
No, we're just solving. We're just like, it's kind of like the last step here. We're just solving for x.
Oh.
Okay, so to do that, I mean, the short of it is you undo addition and subtraction
Yeah.
before multiplication and division.
So for the first one, x equals -4/3, and the second one is x equals 5/-2.
In that case, you would bring the negative up, so it'd be -5/2.
Okay.
Good. Okay. Let's move on to third problem, if that's okay with
Yes.
you. All right. So we need to graph these functions, and this is where I guess I need a little bit more information. Are you guys using tables? Are you, using your calculator? Like, what are you doing to graph?
We're doing no calculators.
Yeah. Okay. So the first thing is do you know the vertex for either of these? And you can read it off from the equation, but it's okay if you don't know. I'm just
Yeah, I don't. Or I do, but
okay. So for the first one, it's 5, 4. Where do you think the 5 comes from, and where do you think the 4 comes from? Just looking at it.
the um the 4 because it's added at the
Okay.
end. So like the other one would be -5 for y.
Right. So what some students remember, and I'm going to write the standard form above it, is that the first value of the vertex, it's the opposite of the number inside here. So if you see a subtraction by 5, it's +5. The other number of the vertex is the number off to the right. Okay, so for the second one here, the vertex would be at 8, -5. The reason
Because
it's 8, but
inside of the parentheses is opposite, right?
right,
This
and
one
then
is.
it's the other number.
Okay.
Okay, now to graph, you're supposed to have 5 points. And this is often uncomfortable for students, but the first point you always graph is the vertex, which is right in the middle. Okay. And then you choose 2 x values smaller and 2 x values larger. Okay, now to get the y values, you have to put each of these x values into the equation, which at first glance seems like a lot of work. Okay. But there's some symmetry that we can use, and you'll find that actually 6 and 4 give you the same output, 7 and 3 give you the same output because of symmetry, and we'll see that in a moment. So let's first find h of 6, and what that means is h of 6 means to put 6 in for x here. So it's -6 - 5 squared plus 4. So order of operations says to subtract first inside parentheses, then square, then negate, then add 4. Would you attempt to simplify this for us, please?
Okay. I don't know.
Okay, maybe you got to give this a try. I mean, I've given you the steps. You 6 - 5, then you square the result, then you negate it, then you add 4. You got to give this a try. And if you want to use a calculator, like I know it says no calculator. I don't care if you use a calculator, but because we need to move through this if we can. Um, we can deal with the no calculator stuff later.
So 3
Yes.
or yeah.
Okay. Now I'll do h of 4. -4 - 5 squared plus 4. So 4 - 5 is -1. -1 squared is +1. +1 negated is -1. Plus 4 is 3. And that's what I meant by this symmetry.
Yeah.
Okay. So you don't have to do all of them. You just have to do whichever one correctly. All right. So will you try h of 7 for us, please?
Yeah. Is it 0?
Which means the other one is 0. All right, so what I recommend is graphing as you go, which means that we really want to graph these points here. So, X and then Y, X and Y and so on. So 3, 0. I gotta scroll here all the time. 4, 3, 5, 4, 6, 3, 7, 0. Okay. Now, once you graph it, you really need to make it kind of smooth and nice. Like you don't want to draw straight lines. You want some curvature. Like you don't have to be artistic, but just don't make it look like straight lines. That would be bad.
1, 2, 3, 7, 0. Okay.
Okay, so now for the other one, the M of X, it's the same thing. You go right to the vertex, you put that in the middle, and then you choose points too smaller, too larger. All right, so I would like for you to give me the results for putting 9 and 10 into this function here.
Okay. -6 and -7.
I agree with the first one. For 10, it is -9. 10 minus 8 is, oh, you know what? I apologize. You are correct. And I wasn't thinking. This is not, that's odd. I think your instructor meant to put a 2 there, but maybe not. Maybe not. So we actually didn't need to do all this to graph it, but nevertheless, here are the other points. It's just a straight line. I'm surprised that you don't think there's any corrections to this? Subform and 3 quadratic forms. I guess it could be correct. I guess it is. The other ones, yeah, the other ones are similar. Okay. So for a line, you don't need this many points. You actually only need 2 points.
Yeah.
So I apologize for that. And I'm gonna put a different color here just to make it stand out. So 10. Let's go 8, -5, 3, 4, 5, 6, 7, 8, -1, 2, 3, something like that. And then 7. Let's go. I don't know. Let's go 6, -3. 3, 4, 5, 6. -3. And then you really should use a ruler. It doesn't matter for me because I'm not grading it, but whatever your instructor wants you to do, do that. Make sure you put arrows on the end, and now you have it.
So their intersecting point would be 3, 0.
And probably, so I've not graphed this one really all that well. It's probably this one over here. That's probably the other one. Now we can do it exactly, but I think the idea is to use the graph 3, 0, and then 4, 5, 6, 7, 8, 8, -5. which is, yeah, those both work.
E negative 5.
Okay, let me know when we can go to part B.
I'm ready.
Okay, so part B says to write h of x in factored form. You might be like, why would I do that? Well, the idea is that you can move between forms here. So there's a couple of ways to do it. You could expand this if you wanted. You can also look at the graph and determine the intercepts. Which way do you think you would do it in class or were shown in class? Do you know?
Probably the intercepts.
Okay, so the intercepts are at 3, 0 and 7, 0. So factored form is a x minus b, x minus c, where b and c are the zeros. And you might have a slightly different formula in your class, but basically b is 3 and c is 7. And we'll get to a in a moment. So h of x equals a x minus 3, x minus 7.
And is that it?
Well, we've got to find a, but the a is common to all the forms. So a is this number out in front, which is -1. There is another way to find a, but if that is sufficient for your instructor, I don't know, you'll have to maybe address that. But a is common to all the forms. So there's a x minus h squared plus k, a x minus b, x minus c, and then there's a x squared plus bx plus c. A is common to all the forms.
Okay.
One of the nice things about it, but you got to check with your instructor because maybe that's cheating. Just it's not really. It's just a shortcut, right?
Yeah.
But I mean, I don't grade your assignments. All right. So the part C is to write. Oh, sorry, not h of x. Not that one. So C is to write h of x in standard form. This one you do have to then expand. Okay. So you have to write -1, x minus 5, x minus 5 plus 4. So do you remember how to FOIL x minus 5, x minus 5?
I remember the word FOIL, but I haven't seen it this year yet.
Okay, so F stands for first times the first. So x times x is x squared. O stands for outside or outer. Some people call this the rainbow method. I've heard that. X times -5, so it keeps the sign, is -5x. I is the inner, so -5 times x, minus 5x. And then L is the -5 times the -5 is the positive 25
Okay.
plus the 4. Okay. Now you typically can always combine the O and the I. They're like terms. You still have this negative out in front. And that gets distributed into everything. So what it does is it changes the signs of everything inside. It's -x squared plus 10x minus 25, like that, plus 4. And then you combine these like terms, -x squared plus 10x minus 21. And that is your standard form.
All right.
All right, we're going to do E next. We actually should have done E from the graph. And then we'll come back to D. Sometimes I do them out of order because they make more sense.
Yeah.
So if you look back at the graph, okay, which I'm going to snip it so we can look at it again. I know you've got it on your paper there, but the range of the y of the h of x, you really want this vertex point, which is 5, 4. Okay, so the range always refers to the y values. And it's the min to the max, or it's the bottom to the top. Okay. And basically you're asking yourself, like, how far down does the black lines go? How far down does this go? And it goes down forever. What is forever in math terms? Do you remember?
Negative infinity.
Negative infinity. And then the top, and it's the y values. You don't care about the x. The top is the y value of 4.
And
Since it's included,
a
you use a
bracket.
bracket. Infinities always go with parentheses. And there's more to that, but that's as far as we can go for the moment.
Okay.
Okay. Any questions on that before we go on to D?
No, I get that
Okay.
one.
And was this really like a pop quiz, like something you did in class?
She said that it was labeled as a pop quiz for her last year, but it was just like an at-home like review one because most of the
Okay.
assignments we do in class get done.
Okay. And the reason I'm asking is not to, like, I'm not trying to get in trouble. It's like, this is a lot of work for a quote unquote pop quiz.
Yeah,
Like
she's a
it's
very. That's one thing I've noticed already is there's at least 2 papers every day we have to do.
wow. Okay. So slope intercept form, that's y equals mx plus b. Basically, you have to expand. You have to expand by distributing the negative. So this becomes negative x plus 8 minus 5. And then you combine like terms. So it'd be minus x plus 3. The slope is the number in front of x. The intercept, or the b value, is the other number.
Okay.
All right. Now, I cannot guarantee that we are going to get through both of these, and then lessons are 50 minutes. We might, but if you wanted to, you could prioritize one question or another.
Of the other 2,
Yeah,
could we do number 5?
sure. All right, here we go. Write a function b of x that transforms h of x. So here's h of x. The following ways in the following order. So 5 units to the right. So the way to do this is twofold. You could make a table of the original function, or you can just know your transformations. Which way do you think you would be
Um,
more likely to do it?
the way we do it in class is knowing the way of our transformations.
Okay.
So,
Okay. So currently x plus 2 squared is left 2 units. And that kind of, that's very much like what we were talking about earlier, where it's opposite of what you think.
yeah.
So you might be like, why is it left? It's plus. Well, let's go with it for now. Sometimes things make more sense the more you do them. But to go right now, 5 right, you are going to subtract 5 in there. That's right. 5 units. Because it's already left, you're going left 2 and then right 5. So this becomes x minus 3 squared. So the net result, or like of doing them both, is it's right 3 units. Like the game you probably played as a kid, I did too, where you take 5 steps forward or 2 steps, maybe 2 steps back and 5 steps forward or something, whatever. So that's the first one. Yeah, we did that. Now 3 down. Right now, how many down is it?
It's up 4.
It's up 4. So it's currently up 4. So to go 3 down, we have to subtract 3. That's down 3. So the net result is up 1. Any questions on that so far?
No.
Okay. Now this is really important. I didn't say this, but I will now. The following order, like you have to do it in this order. You can't just be like, oh, I'm going to do it in whatever order I want, because it does matter. It will affect the answer. Reflect it over the x-axis. So to do that, you have to negate the whole thing. Okay. So when you do that, you're distributing this negative to the first term and then to the second term. This right here, x minus 3 squared with the negative in front, this is all one term. So when you give it to the first one here, you're done. You don't have to do anything more than that. So this becomes x minus 3 squared minus 1. So that's probably the most important thing to remember is when you reflect over the x-axis, you're negating everything, not just the first one, which is what a lot of students do. It's everything. And normally I would show you this on Desmos scientific calculator, but since you're not allowed to use a calculator for this, I mean, it would just help for a learning exercise, but it's not. It's,
Yeah. We used
it
that
would.
last year.
Okay.
Okay.
Right. So that is I, okay. Yeah. So there's your new equation. Now to graph it, you need to first determine the vertex. So could you give me the vertex of this?
Is it negative 2, 4?
We're looking at the new function.
Oh. Um, 3, negative 1.
Yeah. And so that goes right in the middle, 3, negative 1. And then you go 2 smaller and 2 larger. So will you evaluate this function at 4 and 5 and tell me what you come up with?
Did you say 4 and 5?
Yes. The reason I recommend those is it's always easier to subtract a larger, larger minus smaller, then you don't have to worry about signs or issues.
Is it 3 or 0 and 3?
Okay. I agree. So that makes this 0 and 3. So now you've got enough to graph this. Go ahead and graph it and then we'll compare results here. I always like to graph the vertex first, but it really doesn't matter. You should see the symmetry though. You should notice, okay, those points all kind of line up. And then just some sort of nice smooth connection between them. Arrows on the end.
Got it. Will the points always like be the same for the top 2 and bottom 2? Like if you find 4 and 5, it'll always be the same for 2 and 1?
Yes, and as long as they're the same distance away, like see how 4 is 1 away from 3 and 2 is 1 away from 3?
Yeah.
Yes, that's why, if they're the same distance away.
Okay.
Okay, the last thing here is to find b of 0. Actually, yeah, that is the last thing on that one. Which sometimes you get from the table, but this time you don't. Just like before, though, you're putting 0 in for x. Could you do that for us, please? Let me know what you come up with.
Is it -10?
It is not -10. It is -3 squared, which is 9 minus 1. So remember, when you square a negative, since it's inside parentheses, it will become positive.
So 8.
Yes.
Okay. And then is that
So that takes care of that problem there. Any questions before we move on to number 4?
I'm okay.
All right. So for number 4, let me see if we can get some more stuff here out of this. All right. How do you want us to graph them, or do you want us to just move on to like part?
Whatever we have time for, I don't mind.
Okay. All right. It's going to be, you're going to get more out of us just doing, not the graphing takes the longest. And like I mentioned, you can go to Desmos and graph them if you need. So f of x in standard form, what that requires you to do is to expand or FOIL. So just like before, you're going to take the first times the first x times x, that's x squared. The outside x times 2. The inside 2x, and then the last 2 times 2 is 4. And then you combine like terms. So you have x squared plus 4x plus 1. And that is in standard form. All right. To do the next part here, to do part C, it would be nice to have the graph, but we can actually do it without the graph for the moment. I'm going to snip in the function here. Could you tell me the vertex of f of x?
-2, 3.
Good. -2, -3.
-3, yeah, because it
So
doesn't.
a rough sketch, let's just say that's -2, -3. Does this graph open up or down? Do you know? And if it
Down,
depends on
right?
this,
Both
it depends on the
negative.
number in front. There's no negative in front. So this one opens up because A is greater than 0. So it looks something like this. So the range, it's two things. If it opens up, it's the y value of the vertex to infinity. If it opens down, it's minus infinity to the y value. So
So
you have to know these.
-infinity.
This one opens up though. This is up. And then this would be down. So since yours opens up,
So -3 to infinity.
yes. And you want to know both of these for that. So really quickly here to close out, to do D and E, it is based again on the graph. And it's based on the X values. These are now the X values of the vertex.
Okay.
There's two possibilities depending on whether it's open up or down, but since we're short on time here, we're basically out of time. Since this one opens up, it's increasing over here, which is -2 to infinity, and it's decreasing in the other side, -infinity to -2. So go ahead and get that down. We do unfortunately have to stop right